we're looking at something like 16. You have 64 to the 2/3. So I don't even look at my denominator. And then I have 343 to the 2/3. So what I do is treat this like two separate problems. I say, all right, I'm going to look at the cube root of 64, and I'm going to look at the cube root of 343. So the cube root of 64 is 4, because 4 times 4 times 4 is 64. So then I say, all right, well, the cube root of 64 became 4. I still have to take into account that square, because remember that this is kind of like 64 to the 1/3 to the 2, and 343 to the 1/3 to the 2. So what I do is I simplify those perfect cubes first, then square them. The cube root of 343 becomes 7, because 7 times 7 times 7 is 343. So then 4 squared becomes 16, and 7 squared becomes 49. Now, your calculator could do those perfect cubes for you. You could square on your calculator. The calculator might struggle if you try to put all of this in there at once. Might actually work. Better? Scroll back through all those pages. Look at 7-4. Look at 7-5. Where are you like, if this was on my test, I have no idea. Because when I wrote your test, I looked at these worksheets and I said, okay, if it's on this handout, it's fair game. So if you looked at this, what can't you do? Let me fix it. On which page? Okay. So we really hate cube roots. So 125 and 216 are perfect cubes. The 2/3 power is again the same as the 1/3 squared. Well, the 1/3 power is just your cube roots. So what you would do is you're really kind of looking at as the cube root of 125 over the cube root of 216 all squared. And if you go to that nifty little paper again, under x cubed, you'll notice 125 and 216. So 125 and 216 are perfect cubes. So they become their cube root, which is the number that comes over here. So 216 is going to become 6. 125 is going to become 5. So I'm going to get 5 over 6 squared. And then 5 squared becomes 25, and 6 squared becomes 36. Better. It's just a matter of seeing those numbers. The ones I thought we were going to hate were the division ones. I thought you were all going to ask me about 29. Can you get rid of, on 29, the square root in your denominator? So if 29 was the problem on your page, do you know how to fix that? Because that's not your answer right now. But that's what it would look like. So if you had that, yes. That's exactly what you would do. So to fix this problem, you're going to multiply the top and the bottom by the square root of 3b. Awesome. Why? Because that takes the square root out of the bottom. And I cannot have a square root in my bottom. So that would become a square root of 3b all over 3b. Because when you have the same square root times itself, the square root goes away. Excellent. How about on 7-5? Again, don't even just look at the ones I gave you for homework. Look at some of the other ones. Can you do 17? Can you do 14? No, I don't. Just picking random numbers at this point. Yeah, that's not bad. Okay. Yeah, I think 14 is a good one. All right. The rule is simplify what you can first. Simplify what you can first. Remember that all square roots can be thought of as totally separate problems from each other. Not that you need to write it that way, but you need to think of it that way. What is the square root of 9? 3. What is the square root of 64? Now, here's where it gets a little trickier. A to the 5th is not a perfect square. So you have to think of it as like A4 and A. So the A4 is going to become A squared, because you take the inside and divide it by 2 to bring it outside. But because on A to the 5 was odd to start, and A is going to stay inside my answer. B to the 4th is even. 4 is even. 4 divides nicely by 2. So 4 divided by 2 becomes B squared. Do I have to rationalize this denominator? No. Because there is not a radical in my denominator. We're done. Yeah. Right? Yeah. So same idea. What I want to do in 20 is see if I can simplify any of these numbers underneath to perfect squares. 48 is 16 and 3. The square root of 16 is 4. So this becomes 8 times 4 square roots of 3. 75 is 25 and 3. So the square root of 25 becomes 5. And 80 is going to have a 4. Well, it's also 16. So 16 and 5. And we know that the square root of 16 is 4. So it's going to become 7 times 4 square roots of 5. Upon doing so, the first two terms become like terms because both have square roots of 3 now. So I can add or subtract the spread numbers together. So I get 32 square roots of 3 minus 30 square roots of 3 plus 28 square roots of 5. And like I said, these become like terms, and you get 2 square roots of 3 plus 28 square roots of 5. Correct? I need to be able to rewrite them from one form to the other. If the power is 1/2, that is equivalent to the square root. So you need to be able to go from rational to radical. The bottom number is your index or your end value that goes on the radical. The number or variable goes inside. The top number goes outside. Alternatively, you can put that number inside, but in order to be simplified, if the directions were to say simplify versus rewrite, you would have to take 4 to the 4. Or in this case, really super fancy. 4 comes out and a 4 stays in. Because if you have 4 4s and you only need 3 of them to simplify. Okay. So again, cube root 2 to the 5th. Cube root 2 to the 5th. They are equal or equivalent. Only on that aspect. The opposite or the reverse of that is to write it as an exponent. The one that everybody goofs up is number 7 because the square root is a 2. The outside power is a 3. That is 10 to the 3x. 9 would be 2, 5/4, 2, 1/3, and 11. It is the cube root of 2, not 2 cubed. What is the rule about a negative exponent? Can we have a negative exponent? No. So if you have a negative, all right, you watched that, right? Like, I did not scroll, it just said, nope, we're going to this page. That's super annoying. Okay. This is the same as 1 over 5x to the 5/4. The directions, however, are asking for radical form. That is rational form right now. So then you have to say 1 over the 4th root of 5x to the 5th power. If you had to simplify, we'll simplify it. 13 is more than I would ask. But 14 and 1/2 power would bring it down as a positive. 1/2 is a square root. Can I have a square root or a cube root in the denominator of my problem? So if I had to rationalize that, so if that's what it looked like on your test, and you had 1 over the square root of 5, you cannot have a square root of 5 in your denominator. So you have to multiply by 1 to get rid of that. Yeah, exactly. So if I need to get rid of the square root of 5x on the bottom, I have to multiply top and bottom by square root of 5x. Making my new answer square root of 5x over 5x. Now, hit me with my questions. Tell me the title on the page and what problem number. Yep. Anytime I have a fraction, I like to break my fraction into a numerator part and a denominator part. Because then I can look at each term individually. So the square root of 16, because 16 is a perfect square, becomes 4. N squared is a perfect square, and it becomes m. 25 is a perfect square and becomes 5. So by breaking it into a top and a bottom and not looking at them as a whole, I'm able to simplify more easily. Now, there's not one on this side. If you had something like 14 on the back page on 7.5, this one's different now. Well, I'll look at that example too. 15 is all we have to do. Yeah, that one's not, that's a good one too, because 128 is not. That's what I was looking for, a non-perfect number. So if you look at 13 on 7-5, 128 is not a perfect square. So even though I'm able to break this up, I'm going to have to rationalize this denominator. So it adds that extra step. So c to the 4th is going to become c squared, because you're going to divide 4 by 2. D to the 7th is going to be like d6 and d. So the 6 is going to become a 3. And the square root of d is going to stay. 128 is going to break into 64 and 2. But what is the square root of 64? 8. So you're going to get 8 square roots of 2. But that leaves a no-no in the denominator. It leaves the square root of 2. So we're going to multiply top and bottom by square root of 2. So this one's like a little trickier than the other problem because now you have all these other pieces in here. So we had c squared d cubed root 2d over 8 times just the number 2. Because 2 the same square root becomes the number. A little better? Any other problems? Yes. So 23 is kind of nice because the inside number and the outside number are the same. So if you think of it like our power to a power, you get 6 times 1/6, or it's like that 6 inside dividing this outside. So 6 divided by 6 is 1. 6 times 1/6 is 1. So we are left with m plus 4. Because the power on the parentheses matches the power on the outside. Any other questions? No. Good? Okay. So 24 is not a perfect cube, but it breaks into a perfect cube and a non-perfect cube, kind of like our square roots. So you would think of this as 8 and 3. Because the cube root of 8 is 2. 10, you would want to break into a number that does divide by 3. So I'm breaking 10 into 6 and 4. So the 4 is, sorry. Yeah, 901. For whatever reason, still the 6 on the outside for me. The 9 is going to divide by 3 to come out as d cubed. The 1, like this 3, is going to stay inside. 7 is 6 and 1. 6 divided by 3 would become 2. Stays behind. So if it's not a perfect cube, you do exactly like a non-perfect square root, but you use